Make sure you have your math workbook open to page 566. Math workbook on 566, and we're going to do a few pages in here on line plots. So the first problem says Ronaldo collects 10 shells at the beach and weighs each of them. He uses a line plot below to display the data. What is the difference between the weight of the lightest and heaviest shells Ronaldo collected? Show your work. So we have the word difference, which means subtract, and we want the heaviest and the lightest. While the heaviest number is 12, there's no shell that weighed 12. So our heaviest number that actually has an X or a data over it is 11 3/4. So that's our highest. And then our smallest number is right here. What is that number? We have to see how many tick marks are between 9 and 10 to know what that number is. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that's 9 1/8 because each of these is an eighth. So minus 9 1/8. Subtracting mixed numbers, we're going to get mad first. So 4 times 11 is 44, 45, 46, 47 fourths. 9 times 8 is 72, plus one more is 73 eighths. We need a common denominator. Our common denominator is going to be 8. We multiply this by 2 over 2. Let's see, 94. And we multiply this by 1 over 1, and so it says 73. So we have 94 eighths minus 73 eighths. So 4 minus 3 is 1, 9 minus 7 is 2, and our denominator stays the same. 21 eighths, this line means divide, so we're going to divide 21 divided by 8. I'm going to come do that over here. So that's going to be 2 times 16, that's 5. So 2 and 5/8 is the difference between his heaviest and lightest shell. The next problem, what is the total weight of the shells Ronaldo collected that weigh less than 10.5 ounces? So 10.5 is right here. We want the total weight of all the shells that weighed less than this. So we know this one is 9 1/8. 9 1/8. So this is 1/8, 2/8, 3/8, 4/8, 5/8. This is 9 5/8. 9 5/8. And then this is 10 1/4, but we have 2 of those. So 10 1/4 plus 10 1/4 is 20 2/4, right? We can work it out over here. Oh, y'all can't see all that. So 10 1/4 plus 10 1/4 is 20 2/4, which is 20 1/2. So we're going to add our 9 1/8, 9 5/8, and 20 1/2. So we're going to get mad. That's 73 eighths. 72, 73, 74, 75, 76, 77 eighths. 41 halves, but we need to make it a common denominator, so we're going to use 8. So we're going to multiply this by 4 over 4, and that is 164 eighths. This is going to stay 77 eighths, and this is going to stay 73 eighths. So now we're going to add 73, 77, and 164. 73, 77, and 164. So that's 10, 14, 14, 21, 2, 3. 314 eighths. But then this line means divide, so we're going to divide 314 divided by 8. 8 goes into 31 3 times. That's 24. 7. Bring down our 4. That's 9. 9 times 8 is 72, remainder 2. So that's 39 and 2/8. 2/8 can be simplified, so it's going to be 39 and 1/4. That's the total of all the shells that are less than 10.5 ounces. Notice we didn't include the 10.5 ounces because it wanted things less than 10.5 ounces. All right, what is the total weight of shells Ronaldo collected most often? So we have to look at the one he collected most often. Let's go back up to our line plot. The one he collected most often is right here because it's got 3 X's on it. That would be 11 and 1/8. But our answer is not 11 and 1/8. They want us to add 11 and 1/8, 11 and 1/8, and 11 and 1/8 because they want the total weight of what he collected most often. Or that would be 11 and 1/8 times 3. Either way, there we go. 11 and 1/8 times 3 would be 33 and 3/8. All right, moving on to page 567. We have a new line plot. It says, how long a line can Miguel make using all the 3/8 inch straps? Show your work. So first we have to figure out what the numbers are on this line plot. We have 1, 2, 3, 4, 5, 6, 7, 8. So they're counting by 8s. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. And they want to know all the length of the line he can make using all the 3/8 inch straps. So 3/8 is right here. That's 1, 2, 3, 4, 5, 6, 7. So 3/8 times 7/1, that's 21/8. And if we divide 21 by 8, divided by 8, that's 2, and remainder 5. So that's 2 and 5/8, and that's inches, because it's inches up here in our key, or in our label on our line plot. Number 2, what is the difference in the length between a line made with all the 3/8 inch strips, so that's 2 and 5/8 that we just figured out here, and a line made with all the 3/4 inch strips? So we're going to have to figure out all the 3/4 strips before we can figure out the difference, before we can subtract. Well, if I look at my line plot, I don't see 3/4 on there. All I see is 8s. But what simplifies to 3/4? 6/8 simplifies to 3/4. So we have 1, 2, 3, 4, 5, 6, 7, 8 times 6/8. 6/8 times 8/1 is 48/8. If we divide 48 by 8, we get 6. So now we're going to subtract 6 and 2 and 5/8. 6 minus 2 and 5/8. Now, several of you might think that this is 4 and 5/8. That is not 4 and 5/8. You have to get mad, okay? You can't subtract 0 minus 5/8. So you have to regroup, and it's easier to get mad than it is to regroup. So remember, this is 0/8. So we're going to get mad with both of these. This is 48/8. This is 16, 17, 18, 19, 20, 21/8. Now I can subtract 48 minus 21 and get 27/8. And if I divide 27 by 8, I get 3 and 3/8. Notice, if I just subtracted 6 minus 2, I would have gotten 4 and 5/8. Not the correct answer. 6 and 3/8. The next page. Miguel uses 2 of each strip length that he has to make a line. How long would the line be? So he's going to use 2 of these, 2 of these, 2 of these, 2 of these, and 2 of these. So 1/4 plus 1/4 is 2/4. 3/8 plus 3/8 is 6/8. 1/2 plus 1/2 is 1 whole. 5/8 plus 5/8 is 10/8. 3/4 plus 3/4 is 6/4. Now we want to add all of these together, which means we need a common denominator. Our common denominator is going to be 8. So we're going to multiply this by 2 over 2 to get 4/8. This is going to stay 6/8. 1 whole is 8/8. This is going to stay 10/8. And this is going to change to 12/8. So now we have 4 plus 6 is 10, plus another 10 is 20, plus 12 is 32, plus 8 more is 40. So that's 40/8. And what is 40 divided by 8? It is 5. Miguel adds another data value so that the difference between the longest and shortest strip length is 3/4. What tape length did Miguel add? So the easiest way to think about this, I want to get 3/4. The difference between two numbers, so I have a number minus another number, the difference between those two numbers is 3/4. Well, if I subtracted 4/4 minus 1/4, I would get 3/4. I already have 1/4 in my data line plot, and I don't have 4/4. 4/4 would be 1, but that's what the question is asking. What tape length did Miguel add? So he could have added 1 whole or 4/4 to his tape length. So he added 1 whole or 4/4 because, I ran into my work there, because 4/4 minus 1/4 is 3/4. Is that the only possible answer? No, but it is the easiest. If Miguel makes a line with all the 5/8 inch strips, what is the total length in inches? So we're looking at 5/8 on our line plot. 1, 2, 3, 4, 5. So we're going to multiply 5/8 times 5 over 1. That gives us 25/8. And if we divide 25 by 8, we get 3 1/8 inch for the length of all 5 of them. How could Miguel use strips of different lengths to make a 4-inch line? So he wants to make something that's a total of 4 inches long. And he wants to use different strip lengths. All right, so I could use 3/4 plus 1/4. That gives me 1 inch. Go ahead and write that down. 3/4 plus 1/4 equals 4/4, or 1 whole. So if I wanted to make 4 wholes, I would need 3 more 3/4 and 3 more 1/4. 3/4, 3/4, 3/4, running out of room there. Plus 1/4 plus 1/4 plus 1/4. So that would equal 1 whole, that would equal 1 whole, and that would equal 1 whole, and that would be 4 total inches. So that would be 4 3/4 and 4 1/4. Is that the only possible answer? No. An easier answer, if we look back at our tape lengths, if I took a half, how many halves would I need to make 4 whole inches? I would need 8 of them. 1/2 times 8 over 1 is 8 halves, and 8 divided by 2 is 4 inches. So there is more than one answer. I could use 8 1/2-inch ones, or I could use 4 3/4-inch ones and 4 1/4-inch ones to make a 4-inch line. Number 1 on the next page, we have a new line plot with burger weights. Use the line plot in the example. Mel cuts the smallest burger in half. What is the weight of the meat in each half? Show your work. So first, we need to figure out what the smallest burger is. So we got to figure out what they're counting by. 1, 2, 3, 4, 5, 6, 7, 8. Counting by eighths, so this is 1/8. And he takes that 1/8 and he cuts it in half. What does cuts it in half mean? When you take half of something, you divide it by 2. So we're going to take 1/8 and divide it by 2. 8 times 2 is 16, but remember, if you start with a fraction, you end with a fraction. So it would be 1/16 of a pound. Notice that line plots are really doing operations with fractions. We've multiplied fractions, we've added them, we've subtracted them, and now we're dividing them. So it's really about knowing your fractions and how to do operations with them, not just about reading the line plot. On number 2, they give you a set of data. An animal doctor's scale weighs animals to the nearest 1/4 pound. The list below shows the weights in pounds of the last 10 dogs the animal doctor saw, and it wants us to create a line plot using this data. So we're going to need a number line. And what is the smallest number on our number line going to be? Let's see. I got 14, so I think I should use 14. And I have 17. I have more than 17, so I think my smallest number is going to be 14. And my largest number is going to be 18. Hopefully I made this long enough. So 14, and it looks like we're going to count by fourths because that's what our data shows here. So 14 and 1/4, 14 and 2/4, 14 and 3/4, 15. 15 and 1/4, 15 and 2/4, 15 and 3/4, 16. 16 and 1/4, 16 and 2/4, 16 and 3/4, 17. 17 and 1/4, 17 and 2/4, 17 and 3/4, 18. Whew, I made it right. So remember, this is 1/4, 2/4, 3/4. So if this is 2/4, that's 14 and a half. So I'm going to go through and put my halves in here. 15 and a half, 16 and a half, 17 and a half. Now I'm going to put X's for my data. 14 and a half, X. 17 and a half, X. 15 and 1/4, 15 and 1/4, 17 and 1/4, 17 and a half, 15 and 1/4, X. 14 and 1/4, X. 16, X. 14 and 3/4, 1/4, 2/4, 3/4, and 15 and 1/4. We've plotted all of our data. Now we're going to use that data to answer the next question. So now we're going to look at the line plot that we just created and see which statement about the data is true. The heaviest dog is 4 1/4 pounds heavier than the lightest dog. So the heaviest dog is 17 and a half. The lightest dog is 14 1/4. So that would be 17 and a half, which is the same thing as 17 and 2/4, and minus 14 and 1/4. Since there is no regrouping involved in this, I can go ahead and subtract without getting mad. So that would be 1/4, 14, 50, 3 1/4. Well, no, that's not a true statement because it's 3 1/4, not 4 1/4. The 3 lightest dogs weigh 43 and a half pounds combined. So the 3 lightest dogs are all right here. That's 14 1/4, 14 2/4, 14 3/4. So 14 and 1/4, 14 and 2/4, 14 and 3/4. So that's 3, 4, 5, 6/4. 6/4 is actually 1 and 2/4, which is 1 1/2. And then if we add 14, 14, and 14, it's 12, 1, 2, 3, 42, plus this one is 43 and 1/2. So that is a true statement, but we're going to check the other ones as well. The 3 heaviest dogs weigh 52.5 pounds combined. The 3 heaviest are right here. So that's 17 and 2/4. Let me find some space here. 17 and 2/4 plus 17 and 2/4. So that's 2/4 plus 2/4 is 1 whole. 17 and 17 is, let's see, 4, 1, 2, 34 plus, that's 35, plus we have to add 17 and 1/4 and 1/4. So that would be 7, 8, 9, 10, 11, 12, 3, 4, 5, 52 and 1/4, not 52.5. And then the 16-pound dog is closer in weight to the lightest dog than the heaviest dog. So the 16-pound dog is here. The lightest dog is here. That's 1, 2, 3, 4, 5, 6, 7 hops away. Or the heaviest dog, 1, 2, 3, 4, 5, 6 hops away. So no, it's not closer in weight to the lightest dog. It's actually closer in weight to the heaviest dog. So that one is not correct. Michelle chose A as the correct answer. How did she get that answer? She must not have subtracted correctly. She did not subtract correctly. All right, moving on to the next page. Juan drives a race car. The racetracks vary in length. To prepare for racing season, he records the lengths in miles of the tracks in the list shown below. Which line plot correctly shows the track data? So we're not, instead of making our own, we're just seeing which of these line plots matches this data. So let's take 1/4 because it's the smallest number in our data, and we're going to count them all. So this is 1, 2, there's just 2. There's just 2 for 1/4. So if we look at our line plots, this one has 2 over 1/4, this one has 2 over 1/4, this one has 2 over 1/4, but this one has 4. So this is not it. All right, the next piece of data is a half. So let's count all our half pieces of data. 1, 2, 3, 4, 5. Now let's go back to our line plots and see which ones have 5 X's. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one's got a 3/8 in here. Interesting. 1, 2, 3, 4, 5. So would 3/8 actually go there? If we were counting by 8s, would 3/8 go there? 1/4 with a common denominator of 8 would be 2/8. So we could have 1/8, 2/8, 3/8, 4/8. Yes, it would go there. Interesting. So it looks like this line plot has the numbers in the right order. Let's check the other line plots. So this line plot here, 1/4, 1/2, 3/8. Is that in the right order? No, because this is 2/8 and this is 4/8. And when we count, we don't count 2/8, 4/8, 3/8. That's not counting correctly. So this is not correct. This line plot here doesn't have 3/8 on it at all. Do we need 3/8 on our line plot? Let's go look at our data. Do we need 3/8 on our line plot? Yes, we do, because there's a 3/8 right here, which should have 1x over it, which this line plot does. So it looks like this is our correct answer. but we're going to finish checking it just to be sure. We have 3/4 next. How many 3/4 do we have? 1, 2. And we do have 2 x's over 3/4. We have 1 7/8 with 1 7/8. We have 1 whole, 1 whole. And we have 1 1/4, 1 1/4. So letter D matches the data, and the numbers are in the correct order. So letter D is our correct answer. Now we're going to use this data here to answer these questions. The longest track is 6 times the length of the shortest track. Well, the shortest track is 1/4. Let's see what we get when we multiply 1/4 times 6. We get 6/4, which converts to 1 2/4, which is 1 1/2, and I had to squeeze that in there. So is 1 1/2 our longest track? No, it's not. So that is false. It is not 6 times the length. The combined length of the 3 shortest tracks is 4/8. So we're looking at the 3 shortest tracks, which would be right here. 2/8 plus 2/8 plus 3/8. 2/8 plus 2/8 plus 3/8. That's 7/8. Is the combined total 4/8? No, it is not. That is false. The combined length of the 3 longest tracks is 3 1/8. The 3 longest tracks is right here. So if we add 1 and 1 1/4, that's 2 1/4. So we're going to add 2 1/4 plus 7/8. We're going to need a common denominator of 8, so this is going to stay 7/8. And this is going to change to 2 and 2/8. So that's 9/8, so that's going to be 3 and 1/8. Ooh, that one's true. Yay, we got a true. Half the length of the shortest track is 1/8 of a mile. So if we take the shortest track, which is 1/4, and we cut it in half, which means we're going to divide by 2. 4 times 2 is 8, but if we start with a fraction, we end with a fraction. So yes, half of the shortest track is 1/8. That is another true answer. Our last page. Sarah owns Sarah's Hardware. She made the line plot below to compare the fuel tank capacity of several lawn mowers she sells. What is the most common capacity of mowers she sells? Well, the most common would be right here because it's got the most X's. But what are they counting by? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. They're counting by 8s. 1/8, 2/8, 3/8, 4/8, 5/8. So this is 5/8. 1 and 5/8. So the most common capacity of the mower she sells is 1 and 5/8. Mark buys the lawnmower with the smallest tank capacity. So that means he bought this lawnmower. He uses 3 full tanks of gas mowing in the summer. How much fuel does he use? So we're going to take 1 1/2 and we're going to multiply it by 3. So we're going to get mad. This is 3/2 times 3 over 1, which is 9/2. And when we divide 9 by 2, we get 4 1/2. So he used 4 1/2 gallons mowing in the summer. And finally, Jordan looks at the line plot above. He says the difference between the most common capacity and the least capacity is 1/4 gallon. He says he knows the difference without subtracting. Explain Jordan's mistake, then find the actual difference between the measurements. So he seems to think that the difference is 1/4. Did he actually subtract the right numbers? I don't think so. Because what he should have subtracted, if we're subtracting the highest and least capacity, would be 2 1/2 and 1 1/2. That is what we should subtract. So let's go back to our problem here. 2 1/2 minus 1 1/2. So if we subtract a half minus a half, that's 0. And 2 minus 1 is 1, not 10. So the difference between them is 1 gallon, not 1/4 of a gallon. So I would say Jordan's mistake is he didn't subtract the correct two numbers. Subtract the correct numbers. So that was a lot of work today involving a lot of operations with fractions. If you don't understand something, please shoot me an email.